Okay, so today's video is going to be a little bit different to our normal videos. Today's video I'll actually be going through our answers for the algebra and equations practice test that you did. And obviously this is for the compacted test. Okay, so question 1 says complete this entire question on the graph provided in Appendix A. You had to graph the following linear relations on the Cartesian plane provided. So your first one was 2x take 4y equals 12. So we're going to start with that one. So for this equation, what I would do first is I would rearrange this so we can get that normal kind of formula y equals mx plus c. So we're going to rearrange that first. So the first thing you're going to do, we're going to try and get y by itself. So you can do this a few ways. This is just one way of doing it. It's not the only way. As I said, there's a few ways of doing it. So I'm going to take 2x from both sides. So that leaves with negative 4y equals 12 take 2x. Then I'm going to divide by negative 4. So y equals negative 3 plus 2/4 x, and then I'm going to rearrange that just so we have that y equals mx plus c kind of way of writing it. So y equals 1/2, I'm going to simplify my fraction as well, x take 3. And from there I'm going to substitute my values in to draw up a table. So x and y, usual values, negative 3, negative 2, negative 1, 0, 1, 2, 3. That is a terrible table. Obviously in your book you would use a ruler and you could work down the page a bit. I just don't have that luxury. And I'll just substitute in my values. Again, work down the page. I'm just going to work where I've got room. So our first x value is negative 3. So y equals 1/2 times negative 3 take 3. So that's going to be negative 1.5 take 3, negative 4.5. So I'm going to write that in my table there, negative 4.5. My next one, y equals 1/2 times negative 2 take 3 equals negative 1 take 3 equals negative 4. Y equals 1/2 times negative 1. So I'm just substituting in those x values, trying to fill in the y values. Take 3, so that's 0.5 take 3 equals negative 3.5. So you can see I've got a pattern here. Every time my y value is actually going down by 1/2. So I'm just going to fill in that pattern for the rest of my values. Okay, so that would be my table of values for the first one. And in your book, you'd record that. I'm actually going to clear the screen now just so I can do a table of values for the second one. If you're in the test situation, what I would do is I would then graph that one and then move on to the second one. But because of the way my page is laid out, I'm just going to do my table of values for my second one now as well. So our second one, we've got y equals negative 2x plus 1. So we can tell already, because of our formula there, this is going to be a parabola. So we're going to fill in our values, negative 2, negative 1, oh, where's my 1? 0, 1, 2, 3. And then we're just going to substitute in those values of x to find y. So first one, y equals negative 2 times negative 3 squared plus 1. So negative 2 times 9 is going to give me negative 18 plus 1, and that's negative 17. For my second one, y equals negative 2 times negative 2 squared plus 1. Negative 2, oh, there we go. So negative 2 times 4 is going to be negative 8 plus 1, negative 7. Running out of space, you'd work down the page. So y equals negative 2 times negative 1 squared plus 1. Negative 2 times 1 is negative 2 plus 1 equals 1, negative 1. Next one is just going to be equal just 1 in general. And then keep going, sorry, but you should be able to see the pattern here. So this one's going to be negative 1, negative 7, negative 17. There we go. Okay, so now we've got our two table of values. Next thing we have to do is graph it. Okay, so I've accidentally put my tables of values in the wrong order. So this one up the top is actually for our second one. It's for our parabola, sorry, negative 2x squared plus 1, and this one down the bottom is actually our linear relation there, so 2x take 4y equals 12. So looking at my axes here, I have just realized actually they are not big enough to plot our parabola. So we'll have to make do. So I'm going to start off with our linear relation first. So our first point is -3, -4.5. So -3, drop down to -4.5 and put my dot there. Our second one, -2, -4. So find the -2, drop down to the -4, put my dot there. -1, -3.5, put my dot there. 0, 3. And then what have I got? 1, -2.5, 2, -2, and 3, -1.5. There we go. So now you would get your ruler. I don't have a rule that I can actually use with the tool that I'm using to do my videos on, so I'm going to have to freehand it, which is obviously a terrible idea. So that is why you use your ruler. You'll connect all the points, extend it out a little bit, put arrows on the end, and then you label it, which is the next crucial point, and you're going to label it with your rule. There we go. Then our second one, I'm going to change the color of my pen to blue just so it can stand out. So our first point is -3, -17. So that is going to be off the page. Okay, I might pause this video, put in a new axis, and we'll try again. Okay, so this is probably going to be a better axis. So now I've got my X and my Y, and I'm going to plot my points. So my first one is X is -3 and Y is -17. So that's going to be all the way down here. There we go, put my dot. My next point, X is -2 and Y is -7. That's my dot here. X is -1 and Y is -1 as well. X is 0 and Y is 1. X is 1 and -1. 2 and -7. And 3 and -17. Excellent. So once you've done your dots at every single point, this is where you freehand draw your parabola. Make sure that the turning point is going to be actually nice and rounded, not a point. So turn it like that. Actually hit your points unlike I just did. Put arrows on the end, and then you're going to label it with your rule, which I've written down over here. So y equals -2x² plus 1. And there you have your graph. Make sure you've hit all the points, unlike what I just did, and put arrows on the end nice and neatly there. I'm going to actually erase that bit there just to make it a little bit neater, and label it with your rule. Okay, so question 2, the following graph shows a linear relation with 2 points indicated. So we've got our 2 points there, and the things we have to do is A, determine the distance between the 2 points. Okay, so your distance, you try and find from here to here. So what you can actually do is turn this into a right-angled triangle. There we go. And now we've got our sides. So we've got A and B. So we can find out the distance using Pythagoras' theorem. So the first thing we have to do, obviously, is find out the length of side A and the length of side B. So we'll do our horizontal length first. I'm going to write up here. Again, I'm just trying to make use of all the space I have in your test paper. Obviously, work down the page. So your horizontal length, and that's going to equal your largest point minus your smallest point. So that will be 3, take -2, which is going to equal 5. And then your vertical length, again, it's the same thing. Your largest take your smallest, which is 6, take -4, which equals 10. Okay, so from there you can use Pythagoras' theorem to actually work out the side of the length of the unknown side. So that'll be c² equals a² plus b². So then you can just fill in your unknown sides. So c² equals 10² plus 5². So c² equals 100 plus 25. C² equals 125. And from there you just find the square root of 125 to find out what C is. So type that into your calculator. So C square root of 125. So that would actually be a third, but I'll write it as a decimal, which is 11.18. So there you go. Your value of C, the distance between the 2 points, is 11.18, and that's rounded to 2 decimal places. So we'll clear this and we can work out the midway point, so the midpoint between the two lines, which is my second one there. Clear that. Okay, so our midpoint, I'll write up here. So we're doing B now, midpoint. Okay, so to calculate our midpoint, it's going to be the average of our x values is going to give us our x coordinate, and the average of our y values is going to give us our y coordinate. So x1 plus x2 divided by 2, that will give us our average x, our mean, which will be in the middle, so that will be our midpoint. And for a y, we're going to do the same. We're going to calculate the mean of the y values to find that midpoint there. 2. So that's -2 plus 3 divided by 2 will give us our x, and our y will be 6 plus -4 divided by 2. So we've got 1 over 2 and 2 over 2, and therefore our midpoint will be 0.51. So that would be our midpoint of our line. So that would be our x and our y coordinates. So your answer would be, the midpoint is 0.51. So that would be our coordinates there. Okay, so the next is C, which is finding the gradient of the line. Clear that. Okay, so our gradient, we all know the formula for our gradient. So it's our rise over our run, and that's equal to y2 take y1 over x2 take x1. Sorry, so it's -4 take 6 over 3 take -2. That's not very clear that that's two different things. There we go. Okay, so -4 take 6 will leave us with -10. Why did that take me so long? And 3 take -2 is 5. From there we can just simplify. So our gradient there is obviously -2. So we have got a gradient of -2 for that line. And that's what you do for C there. Okay, so next is question 3. And this is the last of our CAPS questions. So a triangle has side lengths 5 centimeters, 12 centimeters, and 13 centimeters. Decide if the triangle is a right-angled triangle. Justify your reasoning. Okay, so this question is asking you about Pythagoras' theorem. So we know, according to Pythagoras' theorem, that c squared is our longest side, and that's equal to a squared plus b squared. So if this is a right-angled triangle, 13 squared should be equal to 5 squared plus 12 squared. So we can work that out to see if it is. So in your calculator, you can just type that in. So 13 squared is 169, and that's equal to 25 plus 144. 169 is equal to 169. So yes, so c squared is equal to a squared plus b squared. So you could say, therefore, this is a right-angled triangle. You have to justify it. So we would say, yes, this is a right-angled triangle, as C, which is the longest side, is equal to the sum of each of the shorter sides after they've been squared. There we go. So easy way to prove that was a right-angled triangle. Okay, so question 4, which is the first of our modelling and problem solving questions. A standard step is 13 centimeters high and has a width of 23 centimeters. A wheelchair ramp, is to be constructed to reach a platform that is 4 steps above ground level. Wheelchair access ramps require a gradient of m equals 1 over 12. So we've got a picture there illustrating our steps there. So A, determine how far from the platform the ramp would need to start if it's to reach the top of the platform. Okay, so first we need to know how tall is the top of the platform. So we need to find out this value here. And that is obviously just going to be 4 times 13 because each of our steps is 13 centimeters high and we've got 4 of them. So the height here is times 13 and that's 52. I shouldn't have had to put that into my calculator. So it's going to be 52 centimeters. So that's this value here. Now what we need to do is determine how far from the platform the ramp would need to start if it's to reach the top. Okay, so we've actually got a bit going on here. So we're going to find out how far it has to be. So pretty much we need this and this value here. So we're kind of looking to find how far away it needs to start to have the correct gradient. Sorry. Okay, so the first thing we have to do is find this distance here. This is our unknown bit here. We're going to find the distance. And we can actually do that using our rise over run formula. So our gradient is our rise over run. Now we actually know some of these things. We know our gradient is actually 1 over 12, so that's our gradient, and we know our rise, and we just have to work out our run. So it's 52 over our run. And then we can just use algebra there to solve it. So our run will be equal to 52 times 12. Type that into my calculator, and that's 624 centimeters. So this part here is 624 centimeters. Okay, so that's how far it has to be out. So that's our answer to A. So therefore, the ramp needs to start 624 centimeters from the platform. Okay, so the next thing that we have to do though is we have to determine the length of the ramp. So now we have to determine this part here. So this unknown distance up the top here. So what is that going to be? And if you look at this, we've actually got a right angled triangle. So we can use Pythagoras' theorem there for B. So B, we know that this side here, the height is 52 centimeters. And this side here, which is the length of it, I guess, is 624 centimeters. And we want to know this unknown, which is C. So C squared is A squared plus B squared. So we're just going to add those together. So 52 squared plus 624 squared is going to equal C squared. So I'll type that into my calculator. So 52 squared plus 624 squared. So C squared is actually equal to, let's see that, 392,080. Okay, and now just to find the length, we obviously do the square root of both of those. So C is going to be equal to the square root of 392,080, which if I type into my calculator, square root, okay, so we're going to get approximately, just round it here, 626 centimeters. So that way we have determined the length of the ramp. So first thing, we determine our height, then our distance from the start, and using Pythagoras' theorem, we've been able to actually calculate there the length of the ramp. And obviously, because it's a word question, we're going to answer in words. So therefore, the length of the ramp would be approximately 626 centimeters. So remember, always answer word questions in words, and don't forget to use your units as well. So that's that one there. Okay, so our next question, question 5, is a bit of a long question. You also had graph paper that you could use for your response as well. So the proposed course for a yacht race has been mapped out with the boys positioned at A, -3, -4, B, -1, 3, and C, 9, 8. But the position of the last boy, D, X, Y, is yet to be finalised. Okay, so the race will begin at position O, which is the origin, 0, 0, proceed through the boys A, B, C, and D, and then finish back at the starting point, which is O. Okay, the judge's boat must be placed in the middle of the boys A and C, and in the middle of the boys B and D. Okay, so analyse this situation to determine A, the location of the judge's boat, B, the location of the boy D, C, the greatest distance that the yachts must travel between any two successive boys. And yeah, you can use that graph paper. Okay, so I might go to a new slides. I've got a bit more space to work this out. Okay, so I've put all we know kind of in dot points there. So we know the coordinates of A, B, C, and D. We know the starting point. We know the route they have to take, and we know where the judge's boat has to be. So the first question, A, is locate the judge's boat. So if you wanted to use your graph paper, you could draw up a graph and actually plot all these points. So you could draw up your axes, put this in here, draw them up, so 9, 8, 7, etc., etc., and then from there you could use that to actually do some of your working if you wanted to. But I'm actually just going to use the formulas that we know to work this out. So the first thing we have to do is find the judge's boat. So the judge's boat we know has to be in the middle of A and C. So pretty much that just means what's the midpoint of A and C, and we know how to do that. So the midpoint is going to be the x-coordinate of A plus the x-coordinate of C divided by 2, so the average of the two x's, and the y is going to be the average of the two y's. So the y-coordinate for A plus the y-coordinate, y not x, sorry, plus the y-coordinate for C divided by 2 to find the average, and that will actually just tell us where the middle is for the midpoint. So that will be x is -3, C is 9 divided by 2, y is -4, and then for the C it's 8 divided by 2, -3 plus 9 is going to be 6 divided by 2 is 3, -4 plus 8 is going to be 4 divided by 2 is 2. So therefore we know that the judge's boat is going to be the middle of those 2 points. So it's going to be at the coordinates 3, 2. So that will be its location. So you'd answer that in words. So therefore, the judge's boat will be at the coordinates 3, 2. Okay, so we know where our judge's boat is. So from there we can actually work out what the answer to our next question is. So, okay, our next question asks us to find the location of D. So we know that the judge's boat is also in the middle of C and D. So we know that it's going to be at the point 3, 2. So we can still use our midpoint formula, but in a different way to actually work out D's coordinates. Sorry, it's in the middle of B and D, I should say. So the midpoint, as we know, is going to be the average of our x values. So it's going to be the x for B plus the x for D divided by 2. That will give us that x coordinate, and our y coordinate again is the average. So the y of B plus the y of D divided by 2 will give us that. And now we can just kind of fill this in. So we know that B's coordinates are -1 plus x of D 2, and we know that the B value, the y value, sorry, for B is 3, so 3 plus y of D divided by 2, and this is all going to equal 3, 2. So from there, I'm going to split it up. So we know our x coordinate 3 is equal to -1 plus the x coordinate of D divided by 2. So I can just use algebra there to find out what the x coordinate of D is. So I'm going to multiply both sides by 2 first. So nope, that's not correct. So 3 times 2 is going to give me 6. So -1 plus x coordinate of D is going to equal 6. So I'm going to get rid of that -1 by adding 1 to both sides. So there we go. So we now know that the x coordinate for D is going to be equal 7. And now we just have to work out the y coordinate. Now I'm running out of space, so I might do it up here. Please don't set it out as horribly as I've done. Work down the page. So our y coordinate we know has to equal 2. And that equals the y coordinate of B plus the y coordinate of D divided by 2. So I'm going to multiply both sides by 2 to get rid of that. So 4 equals 3 plus yd. Take 3 from both sides to get the y coordinate for D. So from there, we've actually worked out our coordinates of D. So therefore, the location of D is 7, 1. So we've used our midpoint formula and we've just kind of worked backwards to work out the coordinates that went into finding that midpoint. Okay, so the next part is C. Sorry, I had to pause that, had a coughing fit, so sorry if the video is a bit jittery here. Okay, so our next question is C. We had to calculate the greatest distance the yachts travel between any two successive buoys. So we know our starting point is the origin at 0, 0. They then have to go to A, then B, then C, then D, and then back to the origin. Excuse me. So to do this question, we just have to work out the distance between each of these points. So if you've drawn that up on your graph, obviously you can calculate the distance using your graph. I'm going to show you the mathematical way to do it just because it's easier for me to do it that way using the equipment I'm doing, and obviously it's still a perfectly valid way of doing it. So the first distance we're going to have to calculate is the distance from the origin to point A. So we're going to use our formula for distance. So we're going origin to A. So our distance is going to be equal to the square root of x2 take x1 plus y2 take, oh, and that's squared, sorry, y2 take y1 squared. Okay, so then we're just going to fill in our values there. So the square root of, so x2 is -3, so -3 take x1, which is 0, squared, plus y2, which is -4, take 0 squared. So that's the square root of -3 squared plus -4 squared. So that's the square root of -3 squared is 9, -4 squared is 16, so 9 plus 16 is 25, and the square root of 25 is 5. So therefore our distance from the origin to A is going to equal 5. So we'll do our next one. Our next point is going to be the distance from A to B. So again, our distance is equal to this to x2 take x1. So x2 is -1 take -3. -1 take -3 is 2. So 2 squared plus y2, which is 3, take 4. So 3 take -4, I should say, which is 7 squared. And type that into our calculator. So 2 squared plus 7 squared equals 7.28. We'll do the next one. So our next point they have to go is to C. So they go from B to C, and distance is equal to, so x2 is 9, take -1, which is 10. So 10 squared plus y2, which is 8, take y1, which is 3, which is 5 squared. Ooh, that should be equal to. So now 10 squared plus 5 squared, our square root is rounding that to 11.18. So that's our distance from B to C. Our next thing we have to go is from C to D. Again, our same formula. Distance is the square root of x2 take x1 squared. So x2, oh, I should write in our coordinates from D because we actually calculated those before, and that was 7, 1. So get rid of this and write 7, 1. So 7 take 9 is -2. So -2 squared plus 1 take 8 is -7 squared. So -2 squared is 4 plus -2 squared, 49, square root of that, 7.28. And last of all, they have to go back to the origin. So they have to go from D to the origin. So again, the distance of that is x2 take x1 squared plus y2 take y1 squared, and then the square root of those added together. So x2 for this one is obviously going to be our origin, so it's going to be 0. So 0 take 7 is 0 take 7 is -7 squared, and 0 take 1 is -1 squared. So type that into our calculator here. Oh no, I accidentally cleared that. So -7 square root of 98. Sorry, coughing fit. Okay, square root Okay, 7.07, if I typed that in correctly, which I hope I did. So then that means, no, I didn't actually, sorry, I'll type that in again. Clear that. Square root of 9.89, sorry, clear that. So square root of that. .07. Okay, I did type that in correctly. Sorry. So 7.07 is that distance. So now the greatest distance that the yachts travel between any 2 points is obviously the largest difference we got there. So the first distance that they travelled was actually 5, not the square root of 5. So the first distance from the origin to A was 5, from A to B 7.28, from B to C is 11.18, C to D is 7.28, and D to the origin is 7.07. So obviously the largest distance we've got here is from B to C, so that's 11.18. So you'd write that in a word answer, so therefore the greatest, clear this, 11.18. So therefore the greatest distance is between points B and C with a total distance of 11.18 units, because we don't know if that's kilometers or meters or centimeters or, you know, hundreds of kilometers, whatever. So that would be our answer there for that one. Obviously, as I said, you could have graphed this on your graph paper and used that to aid in your calculations, but using the distance formulas is easier for me on this, and you could have done that one as well. And that's actually the end of this video, so I apologize for the few pauses within this. I'm a bit sick at the moment, so I've had to pause to have a coughing fit and blow my nose, which is not something you want on camera, so I've had to re-record parts of it. And yeah, anyway, we got there. Hopefully this has helped. If you do have any questions, make sure you come and see me or Mr. Eyre in class, and yeah, make sure you understand all the topics we've covered.